Hello everyone. Today I will talk about a proof by contradiction. Thank you for watching. So today the objectives are first I will talk about what is the proof by contradiction, the concept. Then I will explain the procedure and how to use this technique to um, complete a mathematical proof. And then I will give you two examples. And finally, give you a homework uh, after doing a summary. So let's start. So proof by contradiction is a method of proof in mathematics. So that establishes the truth of a proposition by showing a contradiction if we assume the original proposition is false. And it also called indirect proof or proof by assuming the opposite. So the principle of this method is based on the law of non-contradiction. A mathematical statement cannot be both true and false. For example, a number cannot both be even and odd, right? Any natural number can only be either odd number or even number. So that means a proposition Q and its negation not Q cannot both be true. So that's the basic principle of proof by contradiction. So let me explain how to use this method. So suppose you need to prove the proposition P is true. So the first step, you need to assume the proposition P is false, which is what you wanted to prove is not true. So such that not P, the proposition not P is true. So then based on this assumption, then you got two mutually contradictory assertions, which is both proposition Q and not Q are true. So, which means that they contradict each other. Since Q and not Q cannot both be true, so that means the assumption that P is false must be wrong, which means that leads to the result. The proposition must be true. That's the basic steps of proof by contradiction. So let me show you the example demonstrate how to use this method. So suppose we needed to prove this proposition. So a is a natural number. If a to the power of 2 minus 2 multiply a plus 7 is an even number, then a is an odd number. So we need to prove a is an odd number. Of course, a is a natural number here. So we suppose that a is not an odd number. That means that a must be even number. So if A is an even number, then there's an integer c. So we can use C to represent A, which such as A equal to 2 multiply C, because A is an even number, right? So any even number can be divided by 2. So which means we can use 2 multiply C, or short for 2C, to represent A. So then we replace A in the formula that is A to the power of 2 minus A minus 2 multiply A plus 7. Then we got 2C to the power of 2 minus 2 multiply 2C plus 7. So finally we got 4 multiply C to the power of 2 minus 4 multiply C plus 7. So this number can be represented as follows, which is 2 multiply another number, which is in the bracket, plus 1. So because C is a natural number, so the number in the bracket also must be a natural number. So that means the number is A to the power of 2 minus 2 multiply A plus 7 is the odd number, right? Because it can be represented by this. So 2 multiply a number plus 1. 2 multiply another number plus 1. So this means that this number is an odd number. So then this result contradicts to the condition. So we know the A to the power of 2 minus 2 multiply A plus 7 is even number, which is these two contradict to each other. So therefore, the assumption was wrong, which means that the number A is an odd number. We prove it. Simple, right? Let's go to the second example. The proposition, the number square root of 2 is irrational. So here you need to understand the concept of irrational number and rational number. We will use the definition of rational number later on. Okay, so we suppose that square root of 2 is not irrational, such that it is a rational number. So based on the definition of a rational number, that means that there are 2 natural numbers or integer A and B, such that square root of 2 can be represented by the fraction, the A divided by B. So without a law of generality, we assume that the greatest common factor for A and B is 1. In other words, the fraction A divided by B is fully reduced. So this means that both A and B cannot be even number, right? If both A and B are even number, then that will contradict to the greatest common factor for A and B is 1, right? It cannot be, because if they are even number, they have another common factor 2 that is bigger than 1. So, okay, so then because we assume the square root of 2 can be represented a fraction of two integers with a divided by b, then we can square both sides of equation 1 and got this equation, right? So then which become a to the power of 2 equal to 2 multiplied b to the power of 2. So that's equation 1.2. So this equation tells us the a to the power of 2 is the even number, right? Because a to the power of 2 can be represented 2 multiply another number, which means this number is the even number. So here we need to apply the following proposition. If a number, the square is an even number, then the number must be even as well. So can you prove it? Yes, you can. Just apply the proof by contradiction. It's very easy. 2 steps or 3 steps you can prove it. Okay, so here let us just use the proposition. So then by applying this proposition, we got a is also even number because a square is an even number, right? Then because if a is an even number, then there is another integer c, such that a can be represented by c, which is a equal to 2 multiplied c, because a is an even number. So we plug in this value for a into the equation 1.2. So we got the following, which is 2 multiplied c to the power of 2 equal to 2 multiplied b to the power of 2. This can be simplified by to b to the power of 2 equal to 2 multiplied c to the power of 2. So what does that mean? This equation means the number b to the power of 2 is an even number, right? Because it can be represented by 2 multiply another number. So by applying this proposition, we got this result. So b is even also. So then we summarized so far. We found both a and b are even number. So that contradicts to the assumption that the fraction b divided by a divided by b is fully reduced, right? So it's contradicts to what we assumed, that the square root of 2 is a rational number. The rational number is fully reduced. The friction is fully reduced. So which means the assumption is wrong. With the square root of 2 cannot be a rational number. So which we prove it, right? So let me do a summary, which proof by contradiction is a very useful technique. So in mathematics, sometimes for some proposition, if you use the regular method, usually to prove it, it is very difficult. But if you use the proof by contradiction technique, it is easy. Okay, so the mechanism is simple. So if you need to prove a statement or proposition is true, then you just assume the proposition P is false. Then show that this leads to a contradiction. So the code of the contradiction is because of the assumption P is false. So then you prove the P is true. So let me give you a homework. So please use the technique of proof by contradiction to prove this proposition. For all integer n, if n to the power of 3 plus s is an odd number, then n is even number. Thank you for watching. If you like this video, please give a thumb up, and also please subscribe my channel. I will give you another topics next time. Thank you.